Hello, welcome to today's lesson. We're in chapter 5, lesson number 7, and we're going to be using congruent triangles. So in the last few days, we've been going through congruent statements, and at first we had to show that all 6 corresponding parts were congruent in order to get the triangles congruent, similar to what these two triangles that we have here. But then we learned some shortcuts. Okay, and there were some shortcuts that we could use that we did not have to show all 6 corresponding parts. We could just show side, side, side. We can just show angle, side, angle. We can show side, angle, side. We can show angle, angle, side. And we can show hypotenuse leg. So this means you have to have a right triangle. So somewhere in your proof, you would have to say that you have a right triangle. The ones that we found that do not work, there was 2 of them that do not work, was angle, angle, angle. That just shows that the 2 triangles are similar. And the other one was side, side, angle. These 2 do not work. So the 5 shortcuts that do work are these 5. Okay, so that's a quick review of what we've been up to. All right, so is triangle ABC, so let me just trace that. So we're focusing on ABC. Is this triangle congruent to CDA? All right, well, it looks like we have 1 pair of angles congruent, so I have an angle. All right, then probably looks like we can get these sides congruent. So I do have a side. And then what else do they tell us? They tell us that we have parallel lines. So if we have this line parallel to this line and it has a transversal, can't we say that this angle right here is congruent to this angle right here? So it looks like we have single, side, single, so it goes angle, side, angle. So these 2 triangles are congruent by angle, side, angle. Okay, now my question for you is AB congruent to CD? Well, if the 2 triangles are congruent, don't the corresponding parts have to be congruent? So do you agree that AB must now be congruent to DC? So that's what today's lesson is going to be on. Once we have triangles congruent, then can't we get all corresponding parts? So then the 3 remaining corresponding parts are congruent. The 3 remaining corresponding parts are congruent. Now, isn't that a lot of writing and a lot of words? So corresponding parts of congruent triangles will be congruent. So mathematicians have a new acronym, CPCTC. So corresponding parts of congruent triangles are congruent. So instead of us having to write all of this out with these long words, we can just use the short acronym of CPCTC. Corresponding parts of congruent triangles are congruent. All right, let's put this to use. All right, let's see if we can write this proof. Okay, what is the distance across the canyon? Prove it. Okay, so prove it. Can we get these 2 triangles to be congruent? All right, so if we look at this here, what pieces of information do we have marked congruent? So I guess from the diagram, we can say that DB is congruent to BC because that is given. And we are given that angle D and angle C are right. So angle D and angle C are right. So this is why I don't number them for you, because I would put these in the same statement. Angle D is right, angle C is right. That is given. Okay, now the fact that they are right, are they congruent? Are all right angles congruent? So now the fact that they're right, we can now say that angle D is congruent to angle C, because all right angles are congruent. So I don't typically write right angles theorem. You absolutely can. I just write all right angles congruent. Okay, so either one will work. All right, so now the other thing I mentioned here is that DB is congruent to BC by given. Again, you could put that all in step one. It does not have to be its own separate thing. Now, is there a third thing here that this diagram is showing us that we can use? And I think we can use that this angle right here is congruent to that angle right there by vertical angles. So now we have three corresponding parts. We have an angle, the side between it, and another angle. So these two triangles are congruent by angle, side, angle. Well, now that our two triangles are congruent, aren't the three remaining pieces also congruent? So is AC congruent to DC, which is really what we're trying to find? AC is congruent to ED by CPCTC. Corresponding parts of congruent triangles are congruent. And the whole reason we needed that is because we wanted to know the distance across this canyon. Well, across this canyon is from point D to E, which is the same thing from A to C. And so from A to C is 222 feet. All right. So this is the final proof that we're going to go through. So you might want to just stop the video right now and copy everything down and then take a look at it, because this one's a little bit more complicated or intricate. It's got some good logic in it. So you guys just try to figure it out. So pause it, take a look, see if you can write this proof, and then come back and resume the video. All right, we're going to start with our given. So the first thing we're going to put in here is angle 1 is congruent to angle 2, and we're going to put in angle 3 is congruent to angle 4. All right, so we've got two things. So I know ultimately I'm really trying to get this little triangle congruent to this little triangle here. That's what I'm ultimately trying to do. But right now, they have me focused on this big triangle and the other big triangle. Okay, that's what they have me focused on. So I have the two angles. Now, isn't the side CA congruent to CA by reflexive? So now, can't I get those two big triangles, CDA and CBA, are congruent by angle, side, angle? Now remember, if those two triangles are congruent, their corresponding parts are also congruent. So what corresponding parts could we possibly want to get congruent? Well, what about this side right here and this side right here? Can we get CB congruent to CD by CPCTC? Oh, and then look, can't we get this side right here congruent to itself by reflexive? Now, do we have the blue side, the single mark, and the red side? So do we have those two triangles congruent by side, angle, side? And that's what we were trying to prove, is that right there. Okay, so really, we're done with our proof. That's what we were trying to do. Could we now conclude, is DE congruent to EB? So are they congruent? And the answer is yes. By what reason? And it would be CPCTC. So once you get the triangles congruent, all remaining corresponding parts are congruent, which is what we had to use in here in order to get those two little triangles congruent. Okay, that's the whole lesson for today, is using that corresponding parts of congruent triangles, the CPCTC. So once you get your triangles congruent, you're going to look for that CPCTC. All right, today in your homework, it's no online stuff. Everything is going to be writing a proof by hand. So page 281, numbers 3 through 8 and 11. So it needs to be submitted from a piece of paper. All right, good luck on your proof writing.